Hello, welcome to my channel. Today I'm going to speak to you about bisect module from Python's native library. Bisect lets you insert a value in a sorted list without messing up the sort, and I'm going to walk you through step by step how that happens. So let's assume we have a value 5 that we want to insert in a list that's already sorted. I created a list that's not sorted because I wanted to communicate that bisect module or the bisect function under bisect module assumes that your list is already ordered, otherwise it will give you a gibberish result. So make sure that your list is sorted, then you pass it to your bisect function that is part of the bisect module. And now the goal here is to find a spot for 5 without messing up the order of the list. So to do that, what bisect does is clever. So it first finds the center point, and once the center point is found, it compares that center point with the new item. So here you go. So in our center point, which is because our list has a length of 7, the center point will be the 4th item. Well, the irony is the 4th item here is also has a value of 4. So we compare 4 against 5, checking whether 5 is less than or equal to 4. The answer is no. So basically we ignore every item on the left side of that center and do the exact same thing, which is find the center in the remaining list. So in our remaining list, which is 4, 6, 8, the center point is 6. We compare 6 against 5, checking whether 5 is less or equal to 6. The answer is yes. That means now we ignore everything to the right. In this case, it's only 8. So the next step would be to compare the left item against 5, which is 5 less than or equal to 4? The answer is no. Therefore, our sweet spot for 5 will be index 5. So taking in this information, if we want to insert 5 in this list, the best spot to do it without messing up the order will be at index 5, which is next to 4. This is clear, I believe, but it gets tricky when you have repeated items. Like for example, we have 2 4s here. And what happens if we want to insert another 4? That's where the difference between bisect right or bisect and bisect left comes in handy. Practically itself, what bisect left does is it will insert 4 as a first occurrence, which means towards the leftmost side, and bisect right puts as a last occurrence of the all 4s, which is towards the rightmost, and I'll demonstrate that in a second. Right, okay, now we have a new item that we need to add in our previous list. We haven't added 5 because we're just demoing it. So now we need to add this 4 in our ordered list, okay? And we're going to use bisect left function. The Python code looks like this. Oh, here it says bisect right. My bad. I'll quickly fix it here. Left. There you go. Our list is ordered. And then, same step, we'll have to find the center. But now, what we do is, after comparing the center, which is going to be true because we're comparing 4 against 4, checking whether 4 is less or equal to 4, the answer is yes. We will ignore the right side and focus on the left side, right? So the left side, after the center, what remains are 1, 2, and 3. Then we'll have to find the center again, which is 2. Then we compare 2, whether it's less than or equal to 4. The answer is no, because 4 is greater than 2. Newsflash. So now, what remains is we ignore the left side because we know from here the numbers are going to decrease. So we'll move to the right side and see if the remaining item, which is 3, is greater or equal to 4. In other words, if 4 is less or equal to 3. And the answer is no. So we put 4 next to 3, which is at index 3. That's why our function will return index 3. Now, this is, as I said earlier, because it's bisect left, it will put 4 as a first occurrence. And that's where you will see, if we entered 4 here, you would see 1, 2, 3, 444468, putting the new 4 as the first occurrence. Bisect, or the alias bisect right, it does the opposite, and it would put it here, and I'll show you that one in a sec. Right, we have again 4. We haven't inserted 4 again. We could have, and it wouldn't have changed anything in terms of how the flow works. I hope you like this sorting robot over here. Let's go over the process one more time. Finding the center, comparing the center to our new item, and now the difference is here. It starts here. After finding out that 4 is less or equal to 4, we proceed to the right side of our list that are 4, 6, and 8. Then we compare the center, which is 6, and see if 4 is less or equal to 6. The answer is yes. Therefore, we ignore the right side because we know the list is sorted. So right side of 6 is going to be obviously higher than 6, if not equal. So we proceed to the left and compare what we got on the left side with our item, which is 4, and the answer is yes. But because it's bisect right, it will put it right after the existing 4. That's why, even though 4 is at index 4, we get the next index, which is index 5, and it will return index 5. Now, if you want to see a code demo, I can quickly show it to you. All right, this is exactly the code that you saw earlier in the graphics. So we have a new item that we want to insert. The same list, we will sort the list first, and then we use the bisect function or bisect right. We will try both. We run this and it will return index 5. And just for you to see the difference, bisect right, it should run 5, return 5 as well. And here we do bisect left. It will return 3 as we saw in the example. And let's do bisect right here, or just bisect, and it will return 5 as you saw in the example. And there you have it. That is bisect module for you. You don't have to install it. It's part of Python native libraries. Thanks for watching.